My contribution today, hopefully be a contribution, is twofold. One is that I was engaged by Meat and Livestock Australia to look at all the projects that have operated in New South Wales that have investigated these fertilisers and soil treatments. So in other words, just as there's strength in Fiona showing 3 sites, well, we can broaden that out to a number of projects across a number of areas of New South Wales to see whether there are similarities or whether there were differences. And really the interest for Meat and Livestock Australia came from your interest that was generated by that spike in fertiliser prices that we saw from Alan's presentation. There was also this sort of growing belief that somehow fertilisers may be damaging the soil, and I know Fiona's going to talk about that afterwards, and Alan has already addressed that. But there was also the belief that pastures were no longer responding in the way that they used to, and so that was enough for Meat and Livestock Australia to show interest in a number of these projects. The other thing at the same time was the range of treatments that have become available. There's no shortage in treatments that are available to be applied onto the soil or put onto pastures. And so MLA used the producer demonstration site program to fund 4 of the 5 projects I'm going to talk about, and of course the other one we've heard today through By and Long Landcare and New South Wales DPI. And so what I want to talk about in the first part of this presentation is really this across project assessment, and then later on I'm going to talk about the specific results from my neck of the woods in the northern tablelands of New South Wales to a range of treatments as well. So it's a bit like an upside down cake, but we wanted to talk about the across project assessment first because it puts into context the results that we've heard this morning. And it was really about not just the efficacy, so in other words, did they work and how well did the various treatments increase production, but the cost effectiveness, as Fiona has showed us so nicely. And it wasn't just on production, it was in line with that interest in biology of soils, in if you like, in more holistic nature of farming, that notion of where do these fertilisers and soil treatments fit into the whole scheme. And as Fiona has said, there was a shortage of data when a lot of these projects were started. So when I was reviewing the projects, rather than, because you'll see I'm going to get to a slide that talks about the number of different treatments that have been investigated, we're always looking for common themes. So what are the common themes in terms of the products that were tested? And really I'm going to put to you that they either claim to be a source of nutrients, yes or no, or they claim to stimulate soil biology, yes or no. And as yet we haven't seen anyone trying to market anything in this quadrant along the way. And I dare say we won't. But so up here, source of nutrients, yes, could be activated rock phosphate, could be animal waste, etc., etc. Stimulate soil biology along the top there. So it breaks it into, if you like, a 2 by 2. In terms of the review, it starts to mean that we can look at some of the common responses to groups of different treatments. And when we're talking about stimulating soil biology, and Alan has set the scene very nicely for this, which means that I can progress quickly, really products have to do one of those 4 things, that in essence they have to either and/or, these are all and/or things, they have to increase the rate of decomposition of organic material, because until organic material has hit the soil and started to decompose, it's like us, it's living and breathing, and so it's retaining its own nutrients. It hasn't yet passed them on to the next generation of things to come. Or it has to increase mineralisation, and Alan talked about the solubilisation that's come from absorbed nutrients or the mineralisation that's coming from organic nutrients. So it has to become available. Or these products have to increase the plant's access to nutrients, might be stimulating root hairs. And we heard Alan talk about breeding maybe to increase the architecture of root structure, to increase the volume of soil that's explored by roots. Or it might be through better plant health. But they have to work through a mechanism. They can't just work because we say they do so. And using this picture that we've seen this morning, and I think we're going to see again, just to put that into context, that in terms of decomposition, the feces that comes out of animals or the plant residues have to first of all be decomposed and to get into the organic pool. Then microbes are involved as Alan has already said, in terms of making them available to plants, or the other was of course increasing access of the roots to nutrients, or it could be through increasing plant health. So that's really the mechanisms for work. And on the other side, source of nutrients, well, they too have to have a mechanism for working rather than just saying, well, we put it on and therefore it's going to work. So they have to either provide the macronutrients that are listed there, and we've heard a lot this morning about two of those, about phosphorus and sulphur, or they have to provide micronutrients. And it's not just enough to provide them, is it? They have to be provided in a soil solution where it's deficient for plant growth. And so really we're talking about bringing those two separate streams, and they can go together, of course, as well, stimulating soil biology and source of nutrients together. So the 5 projects that I was reviewed range from Tenterfield up near the Queensland border. So these are all on the northern Tablelands. We pretend to have 800 mils of rainfall a year. It's summer dominant. Highly variable landscape through to the south here by and along, and then the most southern site through to Holbrook, which was run by the Holbrook Landcare Network. There was 43 treatments that had been used across these 5 different projects, and that's too many to do an analysis looking at treatments. And there isn't any statistics in this first part of the talk, because unlike Fiona was able to do statistics on the replicated sense at these different sites, these are from all different projects, all different types of fertilisers fitting within a category. And I've just given some examples. These aren't exhaustive. So for instance, this morning we've heard about agri-ash as well, and of course that might sit somewhere between, for what we've heard, less soluble forms or major or micronutrients, depending on what you're looking for. But it gives you an idea that if we go back to that 2x2, that if they are microbial or plant growth or microbial foods, that's some of the named products that were tested in some of those 5 projects. Not all products were tested in all projects, and so it was about putting those together. But you can see that there's a lot of different treatments that have been tested over time, and they've all been tested with replicated plot designs. I wasn't interested in including anything in the review that wasn't replicated. You know, when we go to a project site, and there might, for instance, let's say we chose the Byalong project, which had 3 sites, and at each site, Fiona believed there were 3 replicates of each treatment combination. There might be one replicate, one of those plots that's performing well or performing poorly. And if you looked at that and didn't look any further, you could form the wrong impression. It's like the notion of saying, well, are all men bald? If they looked at me, they'd say yes. And if we continued to look around the audience, we might come to the same view. No, we might come to a different view. You know, it's that whole idea of making sure that we're getting as good a go at the truth, or the current version of the truth. So they had to be replicated. So Holbrook, Wongwabinda, which is just east of Armidale, Tenterfield, Byalong, number of sites, treatments at each site. So the Armidale had 10 treatments, plus or minus lime. So 4 replicates. So I can tell you now lime wasn't effective in increasing perennial pasture growth there, so it made 8 replicates per treatment combination. So we started to get a fair bit of power. For Fiona to show the sorts of statistical differences she did with 3 replicates means the differences are big, and they really are quite meaningful. The typical plot area, so that'd be something like a 5x4, so you can see the 10 to 20 square metres, what the pasture was, and this is the really important column. What was the starting soil chemistry? And Fiona said this morning that the 3 sites here were chosen deliberately to be low in chemical fertility, but not all of the projects that I reviewed were, and the notable exception was the Holbrook site, where the starting soil chemistry was adequate. And they knew that. It wasn't that they didn't know that, but they wanted to test a range of fertiliser and soil treatments, while P and S, phosphorus and sulphur, we've heard today their important role in plant nutrition, when they were already adequate. And so you can start to see across the 5 projects and the different sites that it really gives us a powerful contrast. We've got sites where soil starting chemical fertility is low, sites where it was moderate, and sites where it was adequate. We've got summer rainfall, and we've got winter rainfall, and we've got different soil types, and we've got different people applying and managing the projects, and that's a really important component as well, because we all influence things. We pretend in science that the operator doesn't, but they do in reality. So it gives us a pretty good go at making a comment in terms of what's the efficacy and cost effectiveness of those different treatments. And Fiona's already shown some much nicer pictures, but for those that haven't seen plot sites, this is two of them that I'll talk more about later when they're being established. In essence, you can see that there's an order to it in order to delineate where the treatments are applied, and then they're distributed at random across the sites, and of course the fences put around. And there was a question about grazing of these sites versus cutting, and I can say that the Holbrook site was grazed. It had animals coming on and off, and some sites were mown. So again, if we take this bigger perspective, just because of the way different people do things differently, it starts to give us an overview of whether these responses are robust or not. And so if I categorise the different fertilisers and soil treatments, the 43, into these different categories there, I'll get this right, Fiona, one day, of microbial or microbial foods down to superphosphate, major or trace minerals, so it could be potassium, for example. There was some biodiesel byproducts that were tested in some areas, and other forms of P. And we have the same measure that Fiona's been talking about, which is pasture production increase relative to the untreated control. And we can see that I've got them ranked, so that down here microbial or microbial foods increased on average by about nearly 10% over the untreated control, whereas up here it was an increase of about 50 to 55% over the untreated control. So there was generally a relationship like that. And as Fiona has shown for the Bynalong sites, well, we get the same relationships when we put all the data together across the 5 projects, that those red dots are the kilograms of P applied per hectare per year. And you can see that there's, by and large, a pretty good overlay. The more P that was applied generally, the higher was the pasture production increase relative to the untreated control. And so the Bynalong results are included in this, as well as all of the other project sites. And when we try to put that then into a relationship, so if we're talking about phosphorus being important in most of these sites, most of these projects, all I've done here is down the bottom here is put in phosphorus application in kilograms of P per hectare per year, and we've got this pasture production relative to the control. Now it has to be a percent relative to the control, because if one particular project produced 2 tonnes of pasture, for instance, through the year, and another produced 12, and we started to average those, you could see the one that produced 12 would swamp the importance of the other. So we have to talk about percent, even though it is a bit frustrating, because we want to know kilos at times, because kilos are about driving production, and that's the nice thing that Phil showed in terms of taking the kilos and the quality and putting it into changes in animal production. So getting back to this graph, these are the treatment means for these different projects, and in essence it's showing, isn't it, that as phosphorus application increased in kilograms of P per hectare per year, so did the pasture production relative to the control. And Alan took us through that nicely this morning, and this is now from a much broader range of results conforming with that relationship. So over here, for instance, we might have things like pig manure or agri-ash, or we might have things like very high rates of superphosphate. I should point out to this one here. So we see this curvilinearity. But not all that's good is good everywhere. And so for those that are eagle-eyed are going to see these blue dots down here, and that's the Holbrook site. And the starting soil chemistry told us that the site was already adequate for P&S. So a really important component about having trust in a monitoring system, isn't it, is knowing that when it tells us that treatment isn't required, it's telling us the truth. And when it tells us treatment is required, and they're 2 ends of the extreme. And so this is a really nice example where, with Alan's plot, if we worked on an Olsen P where he gave us a threshold value of 15 milligrams per kilogram, or if it was Colwell, it was roughly double that, maybe 30 to 40 as a threshold value, it started at that. So we wouldn't expect treatments to increase that, and that's what they reported. So where P was limiting, we saw that there was this curvilinear response, and where P was non-limiting, there was no response. And then we moved to pasture quality across these different sites, and not all projects had pasture quality data on all of the treatments in all of the years, and there is a full report of this on the MLA website for those that are interested. Again, breaking them down into, first of all, crude protein in the blue and metabolizable energy in the red, and again, increase relative to the untreated control. We can see there's a general relationship that as the amount of P in the products increase, so did the quality of the pasture. And while this is a slide that Fiona put up, so thanks Fiona for providing it to include again here, because it makes a really important point. We're talking about an average response. So on average, all of those sites where the soil test told us it was P limiting, we got a P response, but it doesn't mean the response will be the same on every farm or on every paddock, and hence that's the importance of monitoring the progress on your own farm. And Fiona, you're going to come back and talk about what are some of those guidelines for monitoring into the future, because we saw from this morning that while the pattern of that relationship is the same amongst the Kiora and the Glenroy sites, in fact the absolute amounts are quite different. And so in terms of doing the economics on it, which Fiona has done, if we didn't have that, then we wouldn't be certain of where those two lie. And there will be some paddocks that struggle to make a response, and it might be because the pasture species aren't there. It might be other things that are limiting along the way. And so we're talking about average relationships that are always a very useful point to kick off. We've often got a predilection to look for the unusual and try and start with the unusual, but I think the awful reality and boring reality is it's the bread and butter where we should have our attention first, and then if that's not working, then we can look around. In terms of the cost of the extra herbage, just to provide some other data and to make you realise how lucky you are to be in southern New South Wales compared to northern New South Wales. This is the Armidale site, so this was 3 years of data. Chicken is chicken litter, single super, half rates, and I'll describe these a bit more in the sandwich part of this talk. Half rates of chicken and single super, various forms of compost, compost 2, compost 1, there's the important one, untreated control. It's the most important treatment in any experiment, because how do we know if we did anything if we didn't have an untreated control? And this is telling us I'm less generous than Fiona, and it wouldn't, anyone who knows Fiona would know it's going to be pretty easy to be less generous than her. Here, these treatments didn't increase pasture growth, so I've got them as a net cost. And they're a net cost in terms of the budget. The most cost-effective treatment in the Armidale site was chicken litter, which was about $100 per extra tonne of pasture grown. Now, these projects here, the Armidale site, differs from Fiona in that Fiona has been applying, as Alan said, if you like, smaller rates of superphosphate, and she's still within that build-up phase. As you'll see, we went hammer and tong to go through the capital application phase. So this represents high rates of P and the response in pasture, cutting out before we enter the maintenance phase where the P application drops, as Alan showed us this morning, but the benefit to pastures remain the same, and we can see the cost effectiveness starts to improve. And when you model that $100, it's predicted over a 10-year period that might drop to $50 or $60 per tonne of extra pasture grown. And when we looked at the other northern tableland site, Wongwabinda, where there was 3 rates of compost versus 3 rates of superphosphate with some standard errors associated around the mean. You can see they're pretty large for the compost. Compost was costing about $260 per tonne of extra pasture, whereas the single superphosphate was around about $80. So these start to look remarkably similar trends to what Fiona talked about, but Fiona was talking about somewhere between 1 and 3 cents per kilogram, so that's 3 and 5, yeah, 3 and 5, so that's $30 to $50 per tonne, and you can see the sorts of numbers that we're talking. We don't get anywhere near that cost effectiveness, and I think there's a number of reasons for that. We don't get a reliable clover content in northern New South Wales like you more likely do with subclover. White clover is a bit like a wallabies breakaway compared to an all black, much less robust, and not prepared to muck in and go for the goal Good for you in terms of having the cost effectiveness, because Alan talked about fertiliser being a high variable cost, but there's a difference between cost and value. And I think in farming we often struggle to see that difference between cost and value. The data that Fiona showed, to my mind, yelled out value. And Phil did the data there in terms of how many dollars per hectare over and above the control, and I sort of took some notes, and there are hundreds of dollars per hectare over that. And it may not apply across the whole farm, nobody's saying that, but on those parts of the farm where land capability and production goals are situated in that way, then it looked to me pretty good value. And then this was just the first 3 years of data showing the same trends that Fiona's talked about already this morning, in terms of there's some key messages, and the messages are that it's in essence that if treatments supply nutrients that are first limiting, they're going to give you the most cost-effective response. So the conclusion from the across project sites were that despite these differences between north and south, we get microlina, we get Danthonia, redgrass, those sorts of summer active or year-long green, annual or perennial grasses. We get those similar compositions as well. We don't generally get subclover, we tend to get white clover at small amounts. Despite all of that, rainfall patterns, and we had a very good 2011 and a pretty atrocious 2013, 2014, 2015. So we had a range of different rainfall patterns, yet we got similar results across those 5 projects, providing support for what Fiona has already presented well today. And so the 2 conclusions that when you look across those 5 sites, and these aren't going to be many because Fiona is going to go into detail about this, is that in essence that if the soil test shows it's P limiting, well, surprise, surprise, the treatments that provided P were most cost effective. And when P and S sulphur was non-limiting, neither the application of microbial foods or products nor the application of P or S were effective at increasing pasture growth. And that was a pretty clear message that came across from those 5 projects. So if soil chemical testing is telling us we've got P as a first limiting nutrient, then we got a response in terms of the data collected from the projects. But when P and S were non-limiting, like in the Holbrook site, it didn't matter what was thrown at it, it didn't increase pasture production. And that generally the treatments that are most effective at increasing pasture growth will be the most effective at increasing pasture quality and will be the most cost effective. And those things generally go hand in hand. And so the review of those 5 projects really pointed to the same conclusions coming out across those sites, which should give you even more confidence if you were at all concerned about the ability to extrapolate the results that Fiona has talked about this morning. So now I'm just going to quickly go back to, well, okay, I've included some Northern Tablelands results, and I haven't told you anything about those projects. And if you're like me, at the moment, you sort of haven't quite shut the gate on whether you believe in the message or not, because you want to know a bit more about the details. And I've got this montage, or whatever we want to call it, because here's some white clover for those that haven't seen white clover in a grass pasture. This is native perennial grass pasture. This plot at Armidale was just on what we'd call a fairly typical sedimentary type soil that hadn't had fertiliser for over a decade. And this was a single super phosphate plot that we get a good year, we get a big increase in white clover content, the season runs out and we end up with a 6-cylinder vehicle operating on 4 cylinders, because where we've had white clover dominance, we then move to loss of perennial grass basal cover. And so while we don't have thistles and we haven't sprayed anything through here, then in essence we've got area of the landscape that's not carrying a plant. We know in our environment basal cover should be 25-30%, and this is well below that. And then eventually, of course, the nitrogen cycle, the nitrogen story starts to kick in, and we start to see some paspalum in this instance. Some high nutrient requiring grasses start to come into the system. So these are all on the one plot, taken over time. And when we look at the Armidale pasture production, and I haven't got the details here, but again, the full report's on the MLA website, but if you can keep in your mind that chicken was applied annually, 2 tonnes per hectare, single super was applied annually at 320 kilos per hectare, so much higher rates than what we were talking about. This is half rates of chicken and single super. Cow come from Ranges Valley at 2 tonnes, so this was a tonne plus half rate of single super. Cow and compost were a mixture of organic material, could be hay, soil, animal manures. Some were turned, some weren't turned, and so they were just designated compost 2, compost 1. This is total herbage mass production across the 3 years of the project, and the colours show significant differences. And really all these blues are no different from the untreated control over time. And so up this end we've got treatments that did generate significantly more herbage, and we can see it goes from 11 tonne down to maybe 8 tonnes, so an extra 3 tonnes produced over that 3 years of the project. And remember, that was costing about $100 per tonne for every extra tonne over the control that was grown. And we look about what about the impact of these treatments on clover content. Clover content is small. You can do the rough rule of thumb, between around about 2.5 tonne and 11 tonnes, so it's averaged 20% over those 3 years, and that was simply because the first year was so good, going way down. And again, the colours show significant differences, and we've got single superphosphate that's providing available P, high rates of S, leading to the highest amounts of legume content. And then we can see again going down, so that the compost treatments and cow manure were no different from the untreated control over the 3 years of this project. Part of I should say, the way that the farmer group who organised this trial, so equivalent to your Bynalong Landcare group, wanted it, was that all of these treatments were the same cost. They were all $125 per hectare per year. Their view was they didn't want to balance it on P, or they didn't want to do it according to recommendations. Their view was that they have a fertiliser budget, and that's their budget, and so that's how they wanted to know how to spend it. And so again, whether that's right or wrong, or you agree with it or not, the fact that all the projects gave similar responses despite being designed in different ways gives us reassurance that they're telling the same thing. In terms of Wongwabinda, this was a 5-year, end of 5 years, looking at untreated compost versus superphosphate. Compost here, this is the average of 3 rates, 250, 500 or 1,000 kilograms per hectare. The typical rate for compost when it was being applied up there, and largely it stopped as a result of these trials, was at 500 kilos per hectare, and the superphosphate was again paired to it for the same dollar value, which meant that we had superphosphate going out at 130, 260 or 520 kilos per hectare per year. So again, we were looking at capital rates of application rather than in that build-up phase. This time the letters and the colours show the letters show significant difference. We can see that compost didn't do anything significantly over the 5 years, taking it from just over 14 tonnes to 16 tonnes. Superphosphate up to over 20 tonnes over the 5 years. So you can work out annual herbage mass productions, and these are annual figures, not just for a season. And then similar trends in terms of clover, the superphosphate increasing clover content. Pasture quality is, in my mind, is key. A lot of the time, it's sort of past now, I'd say, but it used to hear people would say the difference has to be 20% before you could see it in herbage mass. Well, with all respect, I think it's got to be a lot more than 20%, because it's hard to tell differences unless you're measuring them, and it's harder to see quality differences. And one of the things that we see is often when we have farmers looking at response to treatments, they collect DSC days per hectare. Anyone who's into planned grazing or time control grazing, and that's a really good step from doing nothing. But when we lock up the paddock and set stock it with cattle, mostly in our environment, to look at the live weight gain over a period of time as a integrating herbage mass and quality, what we find is that if you rank, say, no treatment to treatment, this different based on DSC days. Do you know what I'm talking about by DSC days? How many days? Yep. If you then compare it on live weight gain per hectare, it goes like that. So DSC days will give us the general trend, but they'll grossly underestimate the value that you're getting from a treatment. So when we look at pasture quality from the Armidale site, remember this was taken in autumn 2014. This was a single measure. And that's probably the worst time of the year in our environment. We tend to be autumn dry and then get a spring rainfall event. And in between autumn and spring, we get about 95 frost. Here we've got, in this instance, crude protein, the untreated control, about 12% crude protein going up to nearly 14%, and metabolisable energy starting at around about 9 megajoules of ME, which wasn't that different, I think, from your untreated control, Fiona, going up to around about 9.5. So maybe it's 8.5 up to 9.5. Now, these differences don't sound much, and Phil's done a great job in showing just how important those differences in quality are. When I put these figures into grass feed, this time I've got steers grazing on the pasture. This is in the computer, of course. It's a great place to have cattle. And keep herbage mass constant and just very quality. It predicts that I'm going to increase growth rate of those cattle by 200 grams a day. You know, that's massive, isn't it? It's massive. And you won't see, in our environment, if I took you to those plots, you'd struggle to see the difference in quality. You just don't see those differences. If we look at Wongwabinda, which has got much more quality data, collected over a 3-year period, and again in the autumn, looking at crude protein, similar trend. It did go up for compost, the crude protein content, significantly so, and then to superphosphate, and then the ME content. Again, if we did the same thing and put steers on that same herbage mass, and of course there wasn't the same herbage mass, there was more herbage mass on super, so I've really put one arm behind the back, then we could start to jig up steer growth by 500 grams a day. And the issue isn't really whether it's 200 or 500 grams a day, but it's hundreds of grams a day in terms of extra growth from quality. And it's difficult to see quality, but one of the things that we see when we start to take a broader look in terms of what's changing in those pastures is that we see, firstly, these are the 3 of the main macronutrients. Both compost and superphosphate increase the magnesium content. In terms of the phosphorus content, looking at it's getting up to over 0.3%. You know, it's getting up near lucerne, really, and these are grass-based pastures. There's very little legume at this time of the year. They're mostly cocksfoot-based pastures at Wongwabinda, and they're operating up at 17% CP, and we always hear cocksfoot's a low-quality perennial grass. Well, like most things, it depends on how we're looked after and how well we shine. And same with the sulphur content. And we know all of these things are also important in rumen fermentation. We know phosphorus and sulphur are key elements in breaking down cellulose and key elements in starting to get fermentation and digestion happening. So it's not a surprise that when we put into simply the crude protein and metabolisable energy content, we get an increase in growth. And grass feed's not even calculating these changes in phosphorus and sulphur content, which would stimulate more intake and stimulate growth along the way. But what happened to soil fertility on these sites? And I'm working backwards, I realise that, but rather than building the story, I've given the answer in the first slide in terms of what treatments increase pasture production. I'm coming backwards. The initial level, these are Olsen Ps. So Alan has said roughly double if you want to go to Colwell P. I choose Olsen P because I just don't want to bother jigging around with phosphate buffering index or phosphorus buffering index to interpret, and I like just having a single value of 15 to set as a threshold. Initial value is 9. No treatment over a 3-year period. You can see what's happened. There's been a drop over time, and then we see that there's this gradual increase until the single superphosphate, which is put on about 80 kilos of P per hectare over that time, has increased Olsen P by about 13 units, which describes pretty well with the 5 easy steps, about 7 kilos of P per 1 unit of Olsen, or about 2.5 to 3 per 1 unit of Colwell. So why am I putting this up? Well, these are the treatments that grew more pasture, and it's not coincident that those are the treatments where we increase Olsen P to the highest level. It's cause and effect. If we look at Wongwabinda, it's the same trend. If we look at the blue, superphosphate, increasing levels of superphosphate give us increasing change in Olsen P. You like that, don't you? Dose response. Whereas with the compost, there's no dose response at all, and it tells you that this is just a chance effect over at this point here. And it's the same when we look to the change in organic carbon. There were some questions about organic carbon this morning. What we want to see is a dose effect. I haven't just forgotten to put the blue bar in. It's essentially 0. There's no change in organic carbon over this point here. Here we've got really a non-meaningful decrease in organic carbon. So very small changes in organic carbon, and not surprisingly so, given that these sites are probably starting at about 2.5% organic carbon, which might mean 30,000 kilos there already. Change in soil biology. Fiona showed no response to treatment, and we showed exactly the same at Wongwabinda. So just to walk through this a bit slowly, here we've got bacteria and here we've got fungi. Active is the same as the fluorescein diacetate assay that Fiona had up in terms of point in time. Are these organisms metabolising nutrients or not? And total, it's the same as microbial biomass. So you can see these things as the same measure. And here we are after the period of time on this site. And if we look at 0, 250, 500, 1,000, that's the level of compost. And I just want you to bear in mind for the superphosphate, it was at the same dollar value, but it was 130, 260 and 520 kilos a single super each year. Essentially, these just look like a madman's breakfast going up and down, which in statistical sense would be non-significant, but it's worthwhile putting up because what's clear is part of the question that came up to start these trials and MLA's interest was that is somehow superphosphate damaging the soil, and Alan has given us a very large emphatic no. So has Fiona, and so has these results here as well, because, you know, if for instance we're taking total fungi, then one could say, well, in fact, which treatments had a more reliable increase? I'm not doing that. I couldn't possibly do that, but you might. Look across there and say, for instance, that is a more reliable increase than what's happened for the compost. So the same message holds, that in terms of effects on soil biology, no. And also when we looked across time, just looking at the impact on soil pH of those large rates of superphosphate, no change in soil pH. So you've heard the conclusions from across the projects, which was in essence that north and south are for the first time in concert with each other. It's nice to see the south is following the north. And when I look at the north, it is really this same old message that we've heard very nicely from speakers this morning. It's really important to work out the deficiencies on your farm. While on most farms, P will be deficient. If you're in the Holbrook area and you just assume that, you would have got it wrong. So it's the very old mantra, isn't it? Don't guess, measure, and it somehow it's still a goodie. P limiting soils, soil treatments provide P most important. And this is a really important one. When treatments increase pasture growth, they increase pasture quality. They go hand in hand. And you know, if we've got more pasture, we're going to have more plant roots, aren't we? And if we've got more plant roots, those 10,000 species per gram of soil, which is just amazing, well, they tend to hang out amongst the roots, I'd reckon, in the rhizosphere. So if you've got more roots, you know, what's going to happen to soil microbes? You're going to have more soil microbes. So I always like to come at it, sorry Alan, plants sit on top of microbes, so that's the order of hierarchy today. Plants are more important in terms of we need food. You know, microbes and us need food. We don't capture things in the soil, at least directly from the atmosphere. Maybe that's not quite true, but the plants do a very good job at that, at capturing carbon. So when treatments increase pasture growth, we get the whole lock-stop go along, and that leads to better animal performance. And again, to repeat, the results from northern New South Wales were entirely consistent from the south. So again, Fiona, thank you for inviting me to speak today.